A smarter brain gets a smarter body. Plenty of progress in robotics has to do with improving the way a robot senses and plans what to do. Its brain, in other words. Those advancements can often happen faster than those that improve a robot's body, which determine how well a robot can move through the physical world, especially in environments that are more chaotic and unpredictable than controlled assembly lines. The military has always been keen on changing that and expanding the boundaries of what's physically possible. The US Navy has been testing machines from a company called Gecko Robotics that can navigate up vertical walls using magnets to do things like infrastructure inspections, checking for cracks, flaws, and bad welding on aircraft carriers. There are also investments being made for the battlefield. While nimble and affordable drones have reshaped rural battlefields in Ukraine, new efforts are underway to bring those drone capabilities indoors. The defense manufacturer X-10 received an $8.8 million contract from the Pentagon in December 2024 for its drones, which can navigate in confined indoor spaces and urban environments. These so-called loitering munitions are one-way attack drones carrying explosives that detonate on impact. These systems are designed to overcome challenges like confined spaces, unpredictable layouts, and GPS-denied zones, says Ruby Liani, co-founder and CTO at X-10. Deliveries to the Pentagon should begin in the first few months of this year. Another initiative, sparked in part by the Replicator project, the Pentagon's plan to spend more than $1 billion on small unmanned vehicles, aims to develop more autonomously controlled submarines and surface vehicles. This is particularly of interest as the Department of Defense focuses increasingly on the possibility of a future conflict in the Pacific between China and Taiwan. In such a conflict, the drones that have dominated the war in Ukraine would serve little use because battles would be waged almost entirely at sea, where small aerial drones would be limited by their range. Instead, undersea drones would play a larger role. All these changes taken together point toward a future where robots are more flexible in how they learn, where they work, and how they move. Jan Leppard from Stanford thinks the next frontier of this transformation will hinge on the ability to instruct robots through speech. Large language models' ability to understand and generate text has already made them a sort of translator between Lippard and his robot. We can take one of our quadrupeds and we can tell it, "Hey, you're a dog," and the thing wants to sniff you and tries to bark. Then we do one-word change. "You're a cat." Then the thing meows and, runs away from dogs. And we haven't changed a single line of code. That's it. If you found this information useful, give it a thumbs up and share it with anyone interested in robotics. Don't forget to subscribe for more updates. Until next time, take care.